Viewers, welcome to our fourth lesson for the grade 10 to 11 geography lesson series from NANCOL. Our topic for today is river processes. Today we are going to look at how to answer some examples of questions by using a specimen paper on alternative to coursework of river study. And with you again today is Einu Akonga. At the end of this lesson, you should be able to record data on a recording sheet and design a recording sheet, present data in suitable graphs such as line graph, isomap, bar graph, pie charts, and scatter graph, analyze data so that you can describe trends and patterns or anomalies and similarities, make a conclusion on the hypothesis by supporting your conclusion with statistical evidence. For us to grasp our learning objectives well, we are going to use an example of a study that was conducted by other learners as our specimen. However, you need to make sure that different studies requires different methodologies and approaches in order to produce relevant and suitable results. Therefore, what you learn in this specimen or sample paper that we are discussing today is important to make relevant application to other field survey by knowing that methodologies and approaches may be different. For this lesson, we are going to use the following passage or survey. A group of students visited the local stream and they identified 4 sites along the local stream to investigate changes in the river channel downstream and across the channel. They decided to test the following hypothesis. Velocity is higher downstream and on the inner bank of the meander. Size and shape of bedload change as they move downstream. A recording sheet is one of the most powerful tools that one needs in a field or data collecting survey. It therefore needs to be designed correctly according to the needs and the nature of the survey and the data required. For example, a recording of observation, measurement, counting, questionnaire, interview may have similarity, but the types of data required are different. So the difference in data should also appear when designing a recording sheet. A recording sheet consists of 3 sections, section A, B, and C. Section A contains details for identifying the recording sheet. These include details such as name of recorder, time, date, weather, location, or site. Section B contains instruction for the researcher. For example, repeat the investigation 3 times, take measurement at equal intervals, collect 10 pebbles at each site. Usually the instructions depends on the nature of the survey at hand, whether it's a questionnaire, count, interview, observation, or measurement. In this section, we may include instruction for safety precautions. Section C, you now draw a table where you need to record the data again, and the table must also be able to accommodate the type of data well so that you can be able to extract it accurately for proper presentation and interpretations. During measurements, the results are recorded and presented in various graphs and analyzed. The following are examples of different results that the student might have collected in their study. For hypothesis 1, velocity is higher downstream and on the inner bank of the meander. The student measured velocity downstream at 4 sites and they repeated the measurement 3 times at each site. The results are recorded in the table below. Sites along the river: Site A, B, C, D. Site A, the distance from the source is 5 kilometers. The first measurement was 2.5 meter per second. The second measurement was 2.2 meter per second. The third measurement was 3.1 meter per second. Site B is 10 kilometers from the source. The first measurement was 4.1 meter per second. The second measurement was 3.3 meter per second. The third measurement was 3.7 meter per second. Site C is 15 kilometers from the source. The first measurement was 6.0 meter per second. The second measurement was 6.4 meter per second. The third measurement was 5.7 meter per second. Site D was 20 kilometers from the source. The first measurement was 6.5 meter per second. The second measurement was 6.4 meter per second. And the third measurement was 6.4 meter per second. The student also took several measurements across a meander, and the results are shown in the diagram below. Now you must study the table and the diagram shown and answer some possible questions that come. Remember, what we are learning are skills on how to interpret and present data. Questions. A. Describe how the velocity was measured in table 1 in the diagram. B. Using evidence from the table, what conclusion can you make on hypothesis 1? C. Explain reasons for the results in table 1. D. Use the diagram below and describe and explain the variation of velocity across the stream. E. Suggest reason for the variation in the measurement for trials in table 1. F. Draw a graph to show the average velocity in table 1 for site A to D. G. Describe how the student might have tested hypothesis 2. Size and shape of bedload change as we move downstream. H. Describe and explain the result that student might expect for hypothesis 2. I. Suggest ways on how the student might have improved the results for their next investigation. The answers to the following questions. Describe how the velocity was measured in table 1 in the diagram. In table 1, they used a floating object, stopwatch, measuring tape, ranging poles, and a recording sheet. They put 2 ranging poles downstream. They measured the distance between the 2 ranging poles downstream. They released the float at the first pole while immediately starting the stopwatch. They stopped the stopwatch and recorded the time the float took between the 2 poles. They repeated the investigation several times at several locations to obtain an average. On the diagram, they used a flow meter and a recording sheet. They put the flow meter just below the surface. They recorded velocity at several depths across the meander. For question B, using evidence from table 1, what conclusion can you make on hypothesis 1? The hypothesis is proven or supported. Remember, do not repeat the hypothesis. Do not say the hypothesis is true or false, correct or wrong, and do not say yes or no, even if they ask you whether the hypothesis is supported or proven. You must just say the hypothesis is proven or supported. In case where it is not, you must say it's not proven or supported. Velocity increases as you move downstream. Site D, closer to the mouth, has the greatest velocity of 6.4 meter per second. Site A, closer to the source, has the lowest velocity of 2.6 meter per second. And remember, Here you need to write a general statement but not repeating the hypothesis. Support your statement with data, acknowledge the use of comparison and superlative words. Question C. Explain the reason for the result in table 1. Closer to the mouth, highest volume of water, less wetted perimeter, therefore less friction and highest speed. While closer to the source, the uneven riverbed, lowest volume of water, larger boulders, results in higher friction. This means lowest velocity. Question D. Use the diagram below to describe and explain the variation of velocity across the stream. Describe the variation. Deepest part, slower. Closer to the inner bank, slowest. Closer to the beds, slower. Highest in the center just below the surface, higher closer to the right bank. Explain or reasons for the variation. Closer to the banks, large surface of wetted perimeter, hence more friction. On the inner banks, shallowest part, this increases wetted perimeter and more friction. In the center just below the surface, there is less friction, hence highest velocity. On the surface, lower because of friction from the air. Question E. Suggest reason for the variation in the measurement for the trials in table 1. Vegetation or rocks in the water may have blocked the float. Prevailing wind may have interfered with the flow of the float. Timing errors or no accuracy. Question F. Draw a graph to show the average velocity in table 1 for site A to D. Very important. The graph should have title, draw and label the axis and plot accurately. Or sometimes you may need to complete a graph that is already drawn. You must know how to deal with different types of graph, such as triangular graph, line graph, bar graph, isomaps, pie chart, and the scatter graph. Question G. Describe how the student might have tested hypothesis 2, size and shape of bed loads change as we move downstream. The student will need a vernier caliper or a pebblemeter and a roundness chart index. They blindfold one student. The student walk in any direction for random 5 steps and pick up any pebble next to his or her right toe. Or the students can pick any pebble next to the ranging pole or meter ruler on the riverbed. They use a caliper to measure the long axis of the pebble or the length of the pebble and record the size. They use a roundness chart scale and they compare the shape of the pebble to that in the index. Question H. Describe and explain the results the student might expect for the hypothesis 2. Describe. They would expect the pebble to become smaller and more rounded as we move downstream. Site A closer to the source will have larger and angular pebbles. Site D closer to the mouth will have smaller and more rounded pebbles. Explains or reasons for the results. As the pebble moves downstream, they are exposed to more attrition and abrasion. It is important to mention the erosional processes specifically instead of just saying they are exposed to more erosion. Question I. Suggest ways on how the student might have improved the results for their next investigation. The answers need to be linked to the investigation at hand always. If the student used a float only, you can suggest they use a flow meter or a current meter to measure speed. You can say they must measure the speed at several depths or locations across the streams. They must measure the speeds on different seasons or day. However, answers must always be linked to the investigation at hand. This brings us at the end of our fourth lesson, but it is important to remember the following learning objectives that we have discussed. Record the data in a recording sheet and design a recording sheet. Present data in suitable graphs such as line graph, isomap, bar graph, pie chart, and scatter graph. Analyze data so that you can describe trends and patterns such as anomalies and similarities. Make a conclusion on the hypothesis by supporting your conclusion with statistical evidence. Thank you for your time. Until we meet again.